So you're going to want a fancy calculator today. Don't lose anything from the old units. We're coming back to Chapter 7 later. But what we're going to be doing here is we're going to be looking at describing data different ways. It should be a little reviewy. A lot of work on the calculator. And then the vocabulary can get a little bogging, so be careful. Some words like mean, median, mode. Those should seem familiar to you. And then a new one for some of you is standard deviation, and variance goes along with that. We'll discuss some vocab words in the nearer future. So there's a new worksheet. It's worksheet, I think we called it worksheet 9, which I know seems very random because it's your first worksheet. This is actually the second half of a packet, so it's okay. We'll come back and do worksheets 1 through 8 after we finish this. We were just very concerned about making sure we got through the stuff that we know is on your SAT test. So this is stuff that we know is on there. So what we're going to be given in this first question, we have some test scores from an algebra class. There they are. And I want you to enter the data into list 1. So just like you did before, go to Stat, Edit. And I've already entered mine, of course, but Stat to edit, and then I would suggest you place it in list 1 like I have it, but you don't have to have it in list 1. It can be anywhere. Just make a little mental note where you placed your data. So with your data into list 1, we're going to have our calculator calculate what are called one variable statistics. So back to the Stat menu, but this time go over to the Calculate submenu. And then the very first choice, one var stat, is one variable statistics. So you have one variable entered into list 1. That's what we're looking at. Choose one variable stat. Now on your newer calculators, it's going to ask you if you have a frequency list. So like if you had a tally table where you didn't want to hit like the score of 80 6 times, you would put a frequency list next to it. We don't have that, so just leave it blank. On my older calculators, they don't give you the option for a frequency list, so just put list 1, or it defaults to list 1. Hit enter for calculate as well, and it's going to spit out a whole bunch of info at you. So here's what all this means, and you might want to jot this down somewhere just for your reference. When they ask you for the average or the mean, that is, whoops, pen, there we go. That's this guy right here. This is the mean. X bar is how they sometimes like call that out in a stats class, but it's the mean. It's the average of your data values. This weird looking thing looks like a capital E. It's actually a capital sigma. It's a Greek letter, and it means to sum. So when they say like sigma x, that means that they added all of them together, which isn't really interesting to you because you probably wouldn't want to do that. When they do the sum of x squareds, it's the sum of the squares. And again, you're probably like, why would you want to do that? Back in the day, we had to hand calculate standard deviation and variance, and that was a very important feature, was the sum of the squares. And then this gets a little confusing. So capital S with a subscript of x. This is the sample standard deviation. And then right underneath that, that's a lowercase sigma. It looks like this when you write it. I know like the calculator script's a little weird, but that is our population standard deviation. So you might be asking yourself like, great, do I want sample or population standard deviation? And when you move on to a stats class, that answer is very important, because you're looking at your data sets and you're trying to interpret whether you're going to call it a population or a sample of the population. Now for our work today, what we're going to be doing is we're going to be comparing, technically we're comparing two samples to each other as the end result, which I know makes you think like, oh, well she's going to want me to use sample deviation then. Not the case today actually. We're going to always use, and Mrs. Hoffbauer and I just agree with this for the rest of PreCalc, anytime we ask you for standard deviation, go ahead and assume we want the population, okay? The one with the weird Greek letter sigma. The reason is, when you're comparing two samples to each other, they are like their own populations. The reason you would want to differentiate between sample and population in the future is if you took some data, like for a survey in advisories, for instance, and you didn't get around to surveying all the students, but you wanted to make a conjecture or a claim about all the students. In that case, your data is sample. And when you're trying to like extrapolate your data and talk about the population, that's where it gets a little dicey about which one should I use. For us, for pre-calc, just go sigma, the weird Greek one, okay? On the test, if I ask for it, I'll even put the sigma, the character, so you know exactly which one I'm looking for. All right, N is how many data points you entered, which we clearly could have counted those, but it's 11. And then they give you some information next. It says that the minimum value in your list is 30. That's pretty obvious. And then it says Q1. That is the first quartile endpoint. We'll talk about that in a minute. If you keep scrolling down, there we go. MED, anyone have a thought as to what that stands for? Median, very good. So that's the middle. The middle data point, which you guys know how to find the median by hand, but when you have a nasty set of data, you don't really want to find that. Can we pass that back to her, please? Thanks. Ugh. And then Q3 is the third quartile. We'll discuss what that means in a minute. Max is pretty self-explanatory. It's the maximum data point value. And the reason these Q1, median, Q3, max, and min are important to us is because now we can take our data and we can create what's called a Box-and-Whisker Plot. So that takes us back to the questions here. So the first question says, what is the value of N? Well, they said that, or you can count, it's up to you, but how many test scores did they put in that information? 11 scores. The mean, remember, was from your calculator. That was the X bar, the very first data value they got. It doesn't tell you where to round, so let's just go 2 decimal places, please. So 75.45? Awesome. Now the mode is not given to you. And in the data set we had, it wasn't really big, so just kind of look through it. What does mode mean to you from little kid land? The most frequently occurring data value, yes. Now, be careful because you can't have more than one mode. And if everything just shows up once, that means there's no mode. So it kind of depends on the purpose of the question. Sometimes stats teachers have different rules for mode, but which score shows up the most here? 80 is our mode. Very good. The median was given to you on your calculator. They called it MED. What was it? It was 80 as well. So that's interesting. What we're looking at are the measures of central tendency. Mean, median, and mode are measures of central tendency. And the closer they are together, the less weird your data is. So unfortunately for us, our mean and our median are really not that close together. I mean, they're 5 percentage points off. That's kind of a lot. So let's keep looking. The lower extreme, or the minimum test score. What was that minimum test score they gave you? 30. That poor kid. All right, so then what's the upper extreme, or the highest test score? Of course there's a kid out there who gets 100. And then the range of scores is not given to you, but you guys maybe remember the word range as being the difference between the maximum and the minimum. So the scores range by 70 points. So now as our data analysis gets more intense, maybe we decide that that poor kid who got a 30, maybe he would be considered, or she would be considered, an outlier. You ever heard that phrase before? Okay, so outliers really mess up your mean or your average. So maybe we consider like that child hasn't come to school in 3 months, and maybe I don't count their test score right now, but let's look at everybody else's data. Because if I remove that 30, the average is going to shift quite a bit. If we had time, we could play with that. I just don't want to right now. And then the find the lower quartile for the test scores. Technically what they're asking you for is that Q1 from your calculator, which I think I wrote down somewhere. Was it 70? Okay. But technically speaking, the lower range for the test scores, they went from 30 to 70. I'm going to discuss that with you in a minute. Does that make sense? So the lower, by the way, quartile meaning to break your data into quarters, right? So 25%. So they do this a lot on standardized testing when you guys got like your, I don't know what tests you guys took when you were little, ISATs, IGAPs, iReadies, whatever they were called, I something. And they would tell you like you're in the whatever extreme of the data, and you wanted to be in the 99th percentile or whatever they told you. So this group of kids is in the lower 25 percentile, scoring between a 30 and a 75, or 70, excuse me. So the upper quartile, which starts at Q3, which was what number? 85. So if you want a range of scores, it stretched from 85 up to 100. So the upper 25% of my students were scoring between 85 and 100. So that lower quartile is a little concerning to me. 30 to 70, that's kind of intense. I think that 30 kid is really messing up my data, huh? So the next question, oh, interquartile range. One more before I get to the next stuff. They want you to find the difference between the upper and lower quartiles. So it's found by taking Q3 and subtracting Q1. I forgot what they were. 85 and 70? We're going to look at the graph in a minute. It's going to be called a Box-and-Whisker Plot. Let's actually look at that right now. So, what you're going to do, Box-and-Whisker Plot, yay math. Hey Bob, what do you want to call this? I don't know, it looks like a box with some whiskers on it. Let's call it a Box-and-Whisker Plot. Ready? You're going to take 5 vertical line, little pieces, segments, and you're going to draw them at your minimum, your Q1, your median, your Q3, and your maximum. So our minimum, remember, was a 30. Our Q1 was a 70. Our Q3 was an 85, which would be like right there. And then 100 was our maximum. I feel like I missed some. Oh, median. Who was our median? 80? Okay, how was I supposed to be 5? There's 5. So these middle 3, which are supposed to be the same size, but they're not, we're going to create a box out of them. Oops. Can't draw. That's a problem. Never stopped you before, Abruzzo. All right. We just got done with conics, and now I can't even draw a rectangle. This is for... All right. Let's try that again. Ah. Okay. And then what do you suppose we're going to do with those other 2 little lines? If this is called Box-and-Whisker Plot. Look, I'll make some whiskers, children. Whisker. Whisker. Oh boy. Look at that whisker. That kid in his 30 is really ruining my data. Sorry, kid. Can you see how stretched out that lower quartile is now? There's a very large range, which we already kind of saw that. So what Box-and-Whisker Plots are good for is to look at the spread of the data, and usually what we like to do is compare 2 different data sets. So maybe I'll compare first hour's test scores to third hour's test scores. Because you guys have a much smaller class than third hour, so it's not really fair to be like, how many A's do I have? But if I look at your data as its own little Box-and-Whisker Plot, and I can see, oh boy, you know, my upper quartile in third hour has a much larger spread, meaning my top 25 kids in that class have much larger range of scores, which actually wouldn't necessarily be a good thing on a test. Here, this makes me nervous that something's happening with that low kid, that 30. So what's going on with Mr. 30 over there, or Miss 30? So the first question that we're going to follow up with here talks about what's called an outlier. And I think that 30, that test score, is an outlier. Here's how you figure out an outlier. You take your median, and then you either add or subtract 1.5 times the interquartile range. So this is the interquartile range right here. So to find the smallest possible grade, the lower outlier mark, you're going to take your median, and you're going to subtract 1.5 times the interquartile range, which we just found was a 15. Okay? So I just need from you guys a little more information because I forgot. What was the median? Oh, I should look right here. It's right there. Boom. 80. Minus 1.5 times 15. What you get? Is it 57.5? Okay. So technically speaking, so like right around here, here's 57.5. That's as far as I'm allowed to go out. And if you have any data scores, any scores that fall after that, are going to be considered outliers. So go back to your raw data. Were there any test scores that fell below a 57.5? Yep. Good old Mr. Miss 30. Was that the only one? Okay, so according to statistics, I'm allowed to call that kid an outlier and kind of disregard him or her from the data. So here's what you would do. You would create what's called a modified Box-and-Whisker Plot. And this mark now becomes the bottom of the whisker. Okay. I'm kind of taking some artistic liberty here. Some other things are going to change as well. This is going to get skewed a little differently. But this kid down here, this 30, what you would do is you would mark them with a star. So indicating that I do have a data point down there. But stinks to be you, kid. You're an outlier, so I'm actually not going to talk about you. But look what that did to your data. That whisker is no longer like crazy. You don't have a very large spread on your lower quartile anymore. So I didn't recalculate anything, but that's kind of the idea. We didn't talk about the upper quartile, though, or the upper outlier. So now let's take the median, and let's add 1.5 times the interquartile range. So for us, that would be 80 plus whatever this number is. And it's like 100 and something, right? 1025. So obviously no one scored above 102.5, even little Miss or Mr. Perfect there. So everybody on this upper quartile is counted in our data. We don't have anybody who's considered an outlier. Because you do have to remember, guys, outliers can exist on either end of the spectrum. You know, you might have that one kid who got 100, but when you look at your test scores, like if you take that kid out, your test scores weren't nearly as cool as that. So there's just like that one random kid. You've all had that kid in your class, right? The one who gets 100 every time? Yeah. All right, so then, are there any outliers? Well, we already discussed this. That score of 30. Oh, which scores above are outliers? Yes, sorry, I can't read. The score of 30. Sorry, kid. And this question's a little confusing. I think what they were trying to get at was percentage of your overall population, because the way quartiles work is it's supposed to be 25% of your data, but this question's worded a little stinky, so let's just flat out answer them without really talking about percentages for now. What percent of the students scored above 85? According to Box-and-Whisker Plot, like math, this right here is supposed to have 25% of your data. So I think what they were trying to get you to say was 25%, but if you actually look at your data, and I'm assuming this is all of Miss Williams' kids. Whoops. How many of those kids scored above an 85? These two. So if you count 2 out of 11, that is not 25%. So then I thought, okay, maybe they wanted me to count the 85 as well. Wasn't there 185 in that data set? Yeah. So then it's 3 out of 11, and that's not 25% either. So, oh, it is? 3? But it's not like exactly 25%. It's close. It's closer. Yes, I'm with you. So I think that's kind of what whoever wrote this worksheet, we stole it on the internet, I'm going to be honest. I think that's what they were trying to go for, was like trying to display to you like about 25% of your data is in each part of the Box-and-Whisker Plot. I think that's what they wanted to write. So I don't know. I'm not going to ask you that question because I don't really like the way it's worded. How many students scored above an 85? Well, that was just flat out 2 kids. I'll tell you what Box-and-Whisker Plots are really cool for. Visually comparing 2 different sets of data. So like comparing my classes to Mrs. Hoffbauer's classes. We'd never do that though, because you're all wonderful special angels in our mind. But we might. But that would be a neat little project. Maybe we should do that. Maybe we should talk about homework averages. Hoffbauer, are you listening? Got a project for you. Okay, so working on the back now. This is where your homework's going to come in. So I'm going to do a few of these with you, and then I'm going to set you loose for homework. So 9B to finish it is going to be your assignment. This first example we'll do together. We have Bramley's shop has 6 types of iPhone cases for iPhone 8. And the price is shown for each. So I want you to calculate the mean, which we could easily do without our fancy schmancy stat menu. But then there's standard deviation, which you guys do not know how to calculate by hand. So I'm going to need you to enter this data into list 1 or list 2. I don't really care. Just get it somewhere. Get rid of all my pen. I think I have the data entered into list 2. Oops. Is that the right data? Yeah. All right, great. So yes, I have my data in list 2. So when I go to stat one variable stats for calculation, I have to remember that my data is into list 2. So I got to pull up list 2. There's no frequency list. Let's calculate it. The average or the mean is sitting right there, 22.5, and then we're going to go with let's just call the population standard deviation of 4.92. Now on my key, I'll also write down the other one, but I'll put a little X through it so you guys know like it's not really the one we're looking for today. Jot down that data. 4.92 is the standard deviation that we're looking for. Okay, and you know the minute I transfer screens, I already forgot what it was. Was it 22.5 for the mean? Okay. And then standard deviation of 4.92? Something. Okay. So, in the same shop, they're going to compare the iPhone cases to the Galaxy phone cases. So, here's the data for the Galaxy cases. The mean is also 22.5, so they have the same average price. But their standard deviation is different. It's $2.30 compared to $4.92. Now, without really looking at a normal distribution, you guys are probably concerned with like, what the heck is a standard deviation? It tells you how spread out the data is. So if you think about the mean being their middle number, in the future we're going to see normal distributions where the mean is in the middle. So like both of these have 22.5 in the middle. For the iPhone cases, the data, we'll talk about this later, but it spreads out in each direction, $4.92. For the ease of my math, can we just call it $5? So if I move down $5, we're at like, like $17.50, and if we move up $5, I'm at $27.50. But for the Galaxy case, they're still going to start at 22.5, but the spread of the data is going to go out $2.30. So it's not going to go out as far. So like whatever, $20. And then 24, almost $25. So here's what we have to do now is we have to make a conclusion about what that means for us. So compare the two sets of data, make a reference to the spread of the prices. So here's what I would expect you to tell me. Both types of cases, meaning iPhone versus Galaxy, have an average of $22.50, but the iPhone cases have a larger standard deviation. You can abbreviate because it's a lot of writing. So the iPhone cases have a larger standard deviation, so the prices will vary more. That is a huge run-on sentence. I'm sorry. For a lot of kids, what they like to say at this point is that the range of prices is larger for the iPhone cases. You can make a little note about that. That's a little kid topic from stats that we learned a long time ago, the lowest minus the highest. So sometimes that's easy for us to compare as shoppers. Like, okay, well, the extreme values, like my cheapest case and my most expensive case, is going to be more spread out on the iPhones. All right. These questions are a hoot. So we have an average of 10 types of headphones is $15. The average cost for 8 different types of headphones is $88. And what is the average for all these 18 headphones? If I put them together, like that's our inventory. So this question is pretty straightforward, and you've probably seen these before in like your little kid life. And if you're stuck on these questions, you can just go old school with me, guys. You have 10 types of headphones. And you added them all up, right? So you added them all up, and you got an average of 15. You okay with me setting that up? Now I put a big empty space at the top of that because do you know what each individual headphone cost? No, but like finding an average, normally you would like add them. Okay, so same idea for the next set of headphones. This time we have 8 different headphones, so there's like some mystery number added together, and there's 8 of them, and the average is $88. The SAT prep?
Yeah, was that?
We're going to keep working on it. You don't have to do any more on it.
Okay, and the ski wanted me to tell you that ski.
Perfect. Thank you.
But it wasn't homework at all
Nope. All right, so this mystery thing here, which I probably should call a variable, but whatever. Just call it a box for now. Can you solve for it? Just multiply by 10, right? So whatever this number is, it's going to total up to 150. And whatever this number is, if you multiply 88 by 8, that one I don't know, was what? 704, thank you. Oh my gosh, pen. Any day now. There we go. So if I look at my total inventory for all the headphones, it's $150 worth of inventory plus $704 worth of inventory. Can you guys add those together for me? I know I should be able to. 8, 5, 4. So that's how much money all of the headphones are worth if I add them all together. So if I wanted to average all of them, then you would come back and you would divide by how many headphones you have. Well, guys, how many total headphones are we working with here? 18. So the average for all of the inventory of all of the headphones in the store is $47.44. Awesome. Definitely not the only way to get that question right, guys. There's lots of methods. They all kind of revolve around the same math, though. At some point in your math, you have to do 10 times 15. Technically, that's the last one I'm supposed to do for you. However, I do want you to scoot down to number 3 in your homework. So that question right there, it looks a lot like the one we just did, but it's a little more exciting than the one we just did, so I want to look at it. It says the average height of 10 students is 56 inches, and the average height of a group, including 15 additional students into that 10 students, is 60. That was worded really weird. Here's what's happening, guys. You've got this first group of 10 students where the average is 56. So, like, I'm not going to call it a big empty, like, rectangle anymore. I'm going to call it X. So all those 10 kids are added together. And then when you averaged them, you divided it by 10, and you got an answer of 56. Okay. Now, this other clue is worded poorly, but read carefully. The average height, including 15 students in addition to the original 10 students. So, like, there's some mystery number here, which is like all my total students, right? And if you divided it by all of the students, how many total students are we working with here? 25, thank you. The average of all of the students is 60. So write yourself a little note that this represents the total. What would be another way of saying total? So, like, what is total in this problem? Like, how many groups of students do we got going on here? This mystery X kids, right? Whoever they are. And then plus something else, which I really don't know. But look at the question, guys. The question says, what's the mean height of those extra students? That's what they want me to figure out, guys. Can you quickly solve for X? It's 560. And then you can go ahead and plunk that right there. And now look at this proportion. If you multiplied 25 times 60, you have 560 plus this mystery number equals, I don't know what that is. 1,500, thank you. And then subtract the 560 over. I like how I just randomly use question marks instead of variables. But let's be honest, a question mark is totally a variable. Anything's a variable. A little picture of a unicorn could be a variable. What is this? 9 what? 940. What did we just find? The total number of inches if you added up all of these mystery 15 students. So if their question is, what is the mean height of these 15 students? Well, I would have added up all of their heights, which apparently adds up to 940. And then to average them, I would divide by 15. That was a tricky little question, and I think it was worded weird on top of it. So is it 62.67? Okay, cool. That was a nasty little question. So there's some coming up right after it where, like, you have to read really carefully. Are they just flat out telling me the averages of two groups? Or is this one of those weird ones where they tell me the average of the first group and then I got to go figure out the average of the second group? I like those questions because I have seen that style of question, either the easy one or the hard one, on the SAT almost every year. They like those weird, like, what happens to the average if I mess with you? So, some of their favorite questions. So you're going to do that for homework. Do me a favor. Flip to the next page. Let's talk about displaying data again. So we're going to start talking about different types of distributions now. And a lot of our work is going to be looking at calculator. And I know you guys can enter data. You do a fabulous job of entering data. So there's one question on here that has a ridiculous amount of data, and we're not going to enter it. So we're just going to look at the stuff that's already on our paper. But before we get to that, we have skewedness of our distributions. If you have what's called a symmetrical distribution, it's going to look like this, which we're going to learn later is referred to as the normal distribution, is when you get to more statistics. But this always bothers me. So if the tail, if all the data is clumped to the right, okay, if all the data is kind of clumped up here to the right, and then this weird little tail is swooping off to the left, this is referred to as a left skewed distribution, and I always got it backwards because I'm me. So then one day someone told me, I think of it as the left screwed up. And I was like, okay, I get that. Because the left side of the distribution is the one that looks all screwed up, because there's some data that's like pulling it to the left. I don't know, for years that really boggled my mind why they called that one left skewed, because I was like, it should be skewed right. But apparently the stats community disagrees with me. So that's called left skewed. This is symmetrical, and then obviously this one's going to be called right skewed. So if you want to think of it as the right side is the one that's all screwed up and being pulled, that's how I remember it. So the median, oh, this is kind of cool. They're talking about the measures of central tendency and how some are affected by skewedness and some are not. So we found in that test score question that the average test score, the mean, is very much messed up by outliers, right? So like you have that one low test score and it really screws it up. The median is resistant to it though. It doesn't matter if you've got an outlier above and below your data. Like they're going to be negligible when you look at your data's median. So if you know you have data that is not resistant to pulls of the data, then you might want to consider looking at the median as your measure of central tendency as opposed to mean. So, some words about symmetry. They're going to bring up the 5-number summary again. That's the one that we got on our calculator for the Box-and-Whisker Plot that we just saw. Mean and standard deviation. And then remember today we're going to be using the population standard deviation, the one with the weird Greek letters, sigma. All right, if it is symmetric, then you're allowed to use the mean and the standard deviation to describe the data. If you have skewed data, then you're better off looking at the 5-number summary, which means you're going to be looking at the median and the interquartile ranges and all those sorts of things. So, like our test score question, we had that outlier kid, and he screwed up the data. So the 5-number summary was a better choice. This question's done for you, so we're not going to bother typing all this. Here's what you would have to do, guys. Maybe do some highlighting on your notes. We already know we'd enter our data into list 1. You would turn on your plot 1, and select the histogram option. So usually we do scatter plots, but today we would be doing histograms. Now before you actually look at the graph, because it's going to be all messed up, you're going to want to choose zoom stat. You can manually adjust your window if you want, but zoom stat is just like a really quick surefire way to make a pretty picture. And they noticed that when they graphed the histogram, they got this picture over here, which is right skewed. Definitely not symmetrical. They're calling it positively skewed because those would be the positive values going that way. So they said because it's skewed, I cannot look at the mean and standard deviation as a good measure. So instead, let's get the 5-number summary. So after they went to one variable stat, maybe highlight that part for your homework. So 5-number summary because it's skewed, and then one variable stat. They're looking at min, Q1, median, Q3, and max. And then, I don't think they did much more. So they just kind of wrote down some things they noticed. They said the number of passengers ranges from the min to the max. They just wrote down the min and max numbers. The median is the middle, so they wrote that down. And then the interquartile range, Q1 to Q3, is where they get this fact right here. So half of the airports are between. So that's the interquartile range numbers. So from Q1 to Q3. That's a good representation of your middle 50% of your data. So when your data is all screwed up, you don't really want to look at just the average. It's going to be messed up. All right. This next one, it's on the back side of that worksheet, I think. Although I think it's called worksheet 10, not 9. Again, this one is the screen. It's done for you, but can we just pretend y'all typed this in for a minute? Can I just throw the data at you? Okay, so when it says construct a histogram, this is just on your calc, so write a big note to yourself. You go on your calc, you follow those steps from the previous example, and then it's going to want you to summarize the spread of the data. So, where are we at? I can't even read what's on the screen, and I'm the one who did it. Or Hofbauer did it, but, you know, I stole it from her. Okay, so what do you think about this data? I mean, do you feel like it's symmetrical? No, me neither. I got bad news. I did not type this one in. And I'm really running out of time right now. Ugh, alright. Guys, don't worry about graphing it. But I do need some data. Can you guys quickly type this, I'm sorry, this into list 1? And then I'm gonna pause the video. We're gonna do that for a minute. We'll come back and get some data. All right. So I redrew like a little curve over it. We're going with the fact that this one it's definitely not symmetrical, and we're gonna go with a skewed left. So because it's skewed, we're gonna use the 5-number summary, which I'm gonna steal from my kids here because I didn't type it in. So I need the min, the Q1, I need the median, I need the Q3, and I need the max. So who's my fastest typer? Who's got it? Minimum's what? 17. Q1. Thank you. Median. Thank you. Q3. Cool. Maximum. Awesome. So when I go to like make claims about my data, we're going to kind of steal the kind of claims that they made on the previous airplane or airport question. That the data, what are we even doing here? 20-ounce sirloin. Okay, so the steaks weights range from 17 to 21 ounces. The median is 19.5, and the middle half, or middle 50%, range from, and that goes from Q1 to Q3. So it ranges from 18.5 to 20. Did anyone look at the histogram? I think what the two different histograms here are showing, and bless Hofbauer for doing this for us, if you zoom stat, I think it doesn't actually give you a really great window, so I think they made you go back and adjust the window manually to get a better picture. So like when you chose zoom stat, I think it gave you weird like blocks to count by. And you notice all your data is counting by integers, so I think they went back and they fixed the window manually. Sorry, that was really bad of me to run out of time for that. Okay guys, we did not get as far as I was hoping today. So good news, I can't give you any more homework yet, although if you feel like you have enough information to start the next homework assignment, basically you're going to be finishing, we're going to be working through worksheet 11 and assigning worksheet 11. So try getting a jump start, definitely work on worksheet 9B, and maybe anytime it says practice, that means we're going to be doing practice. So I think 9B and 11B are going to be your assignments. Okay, 9B and 11B. Sorry, that was a bad ending.